All right, welcome to our online, week 2 of our online learning. For this week, we're going to talk about inverse functions. There's going to be 3 videos, that's 8 to 10 minutes probably each video, with assignments. Again, I have the agenda. I think I have the agenda a little bit better this week with the date, what's due the next day. Friday will be a makeup day for late work, but I will have specific deadlines that I want you to follow. In math, it's important not to get behind because what we needed one week, we'll keep adding to it. So make sure that if you have late work, that you go fix it from last week, finish it. You guys have been great about communicating with me via email, messages, messenger, text, phone calls, FaceTime. So whatever way that you need to reach me, I think I sent out a letter to most parents that I'll get the rest of them out this week. So just reach out to me. All right, so first thing, I have a little funny story that I want to share to start with. So I'm videotaping all of my lessons on Sundays because then I go to Algebra school in front and sit in my car and download videos. I was going to download one video at my house, but it was going to take 2 days where I went there and it took about 8 to 10 minutes. So I went to video this morning for my Algebra 1 class, and then after about a 10-minute video, I realized, like, oh, that doesn't look quite right. My camera was shutting off. I'm like, oh, I realized I had the first picture of me starting and then the end. I didn't realize the time wasn't going, the red light wasn't on. So now I can watch every time, making sure that I see the red light. All right, so that was just my my story of the week. So don't just laugh at yourself when you make mistakes and then learn from them. So first thing, I'm going to title each of the videos. This one is 331, this Monday, graphing inverse functions. So f of x equals x cubed. So first of all, we know what the x cubed looks like. It's a cubic function. Okay, so we've already graphed that. We're going to look at, it's our parent function. And so think about what undoes something to the third power. Well, it's the root. So we're going to look at this more specifically. So the inverse function, so this is our notation for inverse. It's f, it looks like to the -1 of x, but it reads the inverse function of f of x. So this is our inverse function notation. So our inverse function would be the cube root of x. Okay, so the inverse function of f of x equals the cube root of x. So we are going to graph this one. We already know what this looks like. We know the point starts at 0. Here, I'm going to put this in the middle. So let's have a table of values. Our original points. So we got 0, 0. It was, if you look back to our table, so basically look at these functions from the parent functions. It was -1, -1. It was -2. If you cube -2, you get out -8. If you put 1 in, you get out 1, 1, and then 2 to the third is 8. So let's graph that. Basically our parent function we looked at from last week. So we got 0, 0. And again, you don't need graphs at all. You can just do it on your own paper. We got 1, 1, -1, and I'm just going to approximate about there. And about the same distance. It's symmetrical with respect to the origin. So there's our cubic function. So there's x cubed. So let's look at the functions for the cube root of x. So we knew it started at the origin, 0, 0. Cube root of 0 is still 0. What's the cube root of 1? Still 1. And the cube root of -1 is still -1. So those 3 points are still the same. But then think about perfect cubes. 8 is a perfect cube. So we have 8. What's the cube root of 8? 2. So 8, 2 is a point. So it goes to the right 8 up 2. So about there. And then the other perfect cube in the other direction would be -8. The cube root of -8 would be -2. So it would be somewhere over here. So it looks like... Okay, so there is our cubic, the long s, and then the cube root function. So there's some things we can look from this example. So if you look at these points, the original points to its inverse points, what happened? So it looks like all they are to find the inverse for the points. If you see that the x and y's are switched, switch x and y. Switch x and y. So if you look at the original, you got -2, -8. Now it's not, the signs aren't changing, just the x and y switch places. So -8, -2. So these were all the same because it's the same values. But look at this one, we can see we got 8, 2. So when we're seeing points, from Algebra 1, when you looked at inverse functions, you might have been given a set of points and asked to find the inverse, which is switch the x and the y. So what we're also going to see is there's another cool thing that happens. And it's this line is y equals 2x. So an inverse, so if I were to fold it, if I'd graph, like we would do this in an experiment, we would do it a couple times with graph paper in our classroom. If I had graph paper, I'd fold it along that line, and we'd see it's a mirror image. So an inverse will reflect the line y equals x. It reflects the line y equals 2x. So it reflects this line. So if you want to try graphing a function and it's inverse, and if you have graph paper, you draw the line y equals x, it's a perfect, if you hold it up to the window, it's its mirror image. Okay, so we're going to walk through this different example. So I'm going to erase my function. I'm going to keep my table because we're going to do a linear function for this one. Okay, so for our second example, what we have is going to be, we have our function. We're going to do, I have written down f of x equals 2x minus 3. So f of x equals 2x minus 3. So let's graph this function. So we go down 3. So that's a good point to plug in. Our starting point was 0, -3. Okay, so we're going up 2 to the right 1. So let's put that point in, which would be 1, or we substitute 1 times 2 is 2, minus 3, 1, -1. Let's go 2, 2, 2, 1. Oh, 2, 2, 4, up 2 over 1. What did I do wrong? 1, -1. Oh, I'm going over 2 here. Up 2 over 1. We're good. Okay, so I could tell by my slope that it wasn't linear. And then let's plug a -1 in. I can go down 2 into the left one, so -1, so -5, -1, -5. And let's go with another positive one, just because it fits my 5 by 5 graph. Let's go 3, 2, 3 times 2, 6, so 3, 3. This is not symmetrical. Let me fix this a little bit. Okay, so we have that function. So we're gonna look about next unit about finding the equation. Today, all I'm gonna ask you to do, so you're given a function, and you're gonna practice this on Delta Math, where you're given a function and you've got to figure out its inverse points. So basically, you need to use 5 points. That's why I have 5 here. So what we looked at from what we already knew, cubic, where what undoes something to the third power is the cube root. So we would switch. So what we can do for these points, we can switch the x and y. So we've got -5, -1, -3, 0, -1, 1, 1, 2, and 3, 3. So all you have to do is graph these new points. So if we got -5, 1, 2, 3, -5, -1, -3, 0, -1, 1. So if you see this slope is up 2 over 1, this slope's a half. It's its inverse. Let's see, negative 1, 1, 1, we're at 2, and then 3, we're also at 3. So if you see that function, okay, so this was my function, and this one is my inverse function. So my f of negative 1, it looks like f to the negative first power of x, but it's read the inverse of f of x. And we'll go more into that tomorrow. So you have to find points. You just switch the x and y's and graph them. That's all I'm going to be asking you today. So if you look, what we just talked about, the cubic, it reflects the line y equals x. If I draw this line, the line y equals x right through the middle of that graph, you can still see that if I were to fold that line, or you can think about this, every point from that line is equidistant. So its point and its inverse is the same distance away from that line. It's symmetrical, reflects. So all I'm asking you today is to be able to find points from the function, maybe write a list like this out to help you, graph those. You need 5 points. I think I have 5 questions for you to do on Delta Math. So do that assignment before you watch the second video. All right, have a good day. Whoops. Okay, anytime now.